Hi guys, Audrey here. Let's do group work 6. So the first question, we can see that we have x's and y's mixed together. So that's a clear sign that we need to be using implicit differentiation. And the first step of implicit differentiation is to take the derivative of both sides as we see it. So remembering that y is a function, so the derivative of y is not 1, it's y prime, and anytime we have a y, we're doing like a mini chain rule. So the first thing we have here is e to the xy. So that's going to be e to the xy times the derivative of xy, so I'm just going to put that as a prime there, plus x to the fourth over y. So that's going to be a quotient rule there, f over g, that's a quotient rule. So we have the derivative of the top, 4x cubed, times the bottom, minus the top, times the derivative of the bottom. The derivative of y is just y prime. Uh-oh, I don't know what's happening. Times y prime, all divided by the bottom squared is equal to 2x plus 0. The derivative of 5 is just 0. Now, that xy right there, it's easy to kind of mess this up because x and y look like one function, but it turns out that this is x times y here. So we have f times g, and we have a product rule inside those parentheses right there. So I have e to the xy, the derivative of the first, that's 1, times the second plus the first, times the derivative of y, which is just y prime. 4x cubed y minus x to the fourth y prime over y squared is equal to 2x. And now we identify these two y primes here, and both of them are in places where there's like parentheses with plus or minus. I could put parentheses around this to make that really clear. So y prime is actually not a factor. We see that we have that division there. So the first thing we're going to do is multiply every single term, every single term by y squared. And that's going to get rid of that fraction we have there. So this is starting our step 2 here. And I'm going to get y squared e to the xy times y plus xy prime plus 4x cubed y minus x to the fourth y prime is equal to 2xy squared. Now, this y prime is a factor. It's no longer in parentheses with plus and minus. It's all multiplication there. Whereas this y prime is still inside those parentheses with a plus or minus. So it's not a factor. So we want to take the chunk that we have on the outside here and distribute it to the things on the inside. So what I'll have here is y cubed e to the xy plus x y prime y squared e to the xy. Then 4x cubed y minus x to the fourth y prime is equal to 2xy squared. So now I have x to the fourth y prime and my y prime here, and y prime is a factor of those terms. It's all multiplication now. It's not like inside parentheses with plus or minus. So now we can finish step 2. We get all of the y primes to the left side and everything that doesn't have y prime over to the right side. So I'll have x y prime y squared e to the xy minus x to the fourth y prime is equal to 2xy squared, and I'm going to subtract those two things over. So minus y cubed e to the xy minus 4x cubed y. So I've subtracted those things over there. Now, that right there is my end of my step 2, so I can go on to step 3, which says to factor y prime out of the left side. Because I made sure that y prime was a factor, I can easily do that just by moving y prime to the front. So I have xy squared e to the xy left in the first term, and x to the fourth left in the second term. And then my final step here, I accidentally wrote a 2 there, that was my step 3. My final step here, my step 4, is to divide by everything on the left side the factor that does not contain y prime. So my y prime will be left over here, and I'll have 2xy squared minus y e to the xy minus 4x cubed y, all divided by xy squared e to the xy minus x to the fourth. And that is my final answer here. So yes, there are things that I could do to simplify this, but I don't need to. I can leave my answer just like that. Okay, so this brings us to the second question. Here, I'm just going to write a little PR. That was a product rule. Now, our second question is also implicit. We also have x's and y's mixed together, but now we have this separated into two parts. First, we want to find y prime, and then we want to find the equation of a tangent line. So I'm going to start by taking the derivative of everything as I see it. Here I have kind of like a g to the power of 4. So I have a chain rule there. I bring the 4 down. I don't touch what's inside. And I subtract 1. So that's to the power of 3. And then I pull out the derivative of what's inside. So that's 3x squared plus 2y. But because y is a function, we multiply by y prime. Then minus 3. Then this equals to 4 plus 3y prime plus the derivative of 24, which is just 0. Now, here I have a y prime. Y prime is definitely a factor of 3y prime. We don't have a problem there. But this y prime is inside parentheses with pluses and minuses. So that means it is not a factor, and we're going to have to take this big chunk on the outside and distribute it to the inside. Now, I could distribute it to the 3 different things, and that would be fine. But to make myself have a little less writing and to do this a little more efficiently, I could also think of this as 3x squared minus 3 plus 2y prime. In other words, I can just kind of move things around, and I really only have to distribute to 2 different things inside, the thing with y prime and the thing without y prime. So of course I could distribute it to all 3, but it'll just be a little more efficient to only distribute it to the 2 things. So what I'll have here is 4 times x cubed plus y squared minus 3x all cubed times 3x squared minus 3 plus 4 times x cubed plus y squared minus 3x all cubed times 2y y prime is equal to 4 plus 3y prime. So this right here where we took the derivative of everything, that was my first step. And now we're working on the second step. We're working on making y prime a factor. And y prime is now a factor of everything. So even though this y prime on the left side is still in parentheses, there are no longer pluses or minuses in those parentheses. It's now just all multiplication. So that y prime is a factor. So we can finish step 2 by moving the y primes to the left side and everything else to the right side using addition and subtraction. So when I'm doing that, I actually can multiply these things together to get 8y prime times x cubed plus y squared minus 3x cubed. And then I'm going to subtract the 3y prime over. Minus 3y prime is equal to 4 minus 4 times x cubed plus y squared minus 3x cubed times 3x squared minus 3. So I just moved things around with addition and subtraction. And now for my step 3, I can easily just factor out that y prime. So I'm going to have y prime times 8y x cubed plus y squared minus 3x cubed minus 3 is equal to 4 minus 4 times x cubed plus y squared minus 3x cubed times 3x squared minus 3. My fourth step, I divide over that non-y prime factor onto the left side, and that will give me my y prime. So y prime is equal to 4 minus 4 and then I divide by that factor from the left side, 8y. And this is my answer to part A. Now, your answer would look a little bit different if you had distributed the 4 times x squared plus x cubed plus y squared minus 3x cubed inside to the 3 different things instead of the 2 different things, but it would be relatively similar. Your denominator would be the same, you would just have 3 terms in the top instead of 2. Okay, so this brings us to part B, and in part B we're finding the equation of the tangent line at -2, 0. So the first thing that we want to do, and I'm just going to write that -2, 0 to remind myself. The first thing we want to do is find the slope, and we find the slope by plugging in the point. So I'm going to get y prime is equal to 4 minus 4, -2 cubed, that's -8, plus 0, minus 3 times -2, so that's plus 6, all cubed. Then 3 times -2 squared, that's 3 times 4, so that's 12, minus 3, all over 8y, that's 0. 0 times anything is 0, so that's just 0 minus 3. So then this is equal to 4 minus 4, 6 minus 8 is 2, -2, -2 cubed is -8, and then 12 minus 3 is 9, all over -3. And then we want to do this calculation, so we do 8 times 4, that's 32, times 9, that's 288. So this gives us 4 plus 288 over -3, which gives us 292, -292 over 3. So it's not the most beautiful of slopes, but it was relatively straightforward to get just from plugging in, as long as we kind of did it piece by piece. And that is a recommendation I have for you guys. When you are plugging in these points for implicit, a lot of times your answers to implicit questions are gross. So separate the plugging in into little smaller sections, and that will help you to kind of make sure you get the right answer. So like I did each part separately before I then multiplied things together and added them together. Okay, so that's my slope. And now my next step is to find my b by plugging in my slope and my point. So what I have here is y is equal to -292 over 3x plus b. Now my y is 0, -292 over 3. My x is -2 plus b. So what I get is b is equal to -584 over 3. So y then is equal to -292 over 3x minus 584 over 3, assuming I did my math right there. Hopefully I did. All right. Okay, so for this next question, we're asked to use logarithmic differentiation to find y prime. And we want to know, is logarithmic differentiation necessary or just helpful? Well, that second question I can answer before I even start the thing. What I see is in my base down here, I have some x's, and in my exponent, I have some x's. So I have x's to the power of x's. So the answer here is that it is actually necessary. So I've got x's down in the base and x's up in the power. So that tells me it is necessary. Okay, so now we will actually do the logarithmic differentiation. I have y is equal to 13 cosecant of 9x all to the power of 4x cubed plus 4x squared. Now my first step of logarithmic differentiation is to take natural log of both sides. So I have ln y is equal to ln of 13 times cosecant of 9x to the 4x cubed plus 4x squared. Now, the second step is to use my log rules to simplify this thing. And the question that we have here is, can I bring that power down immediately, or do I need to separate this 13 away first? The answer is that 13 is not inside those parentheses. That 13 is not also to the power. So everything inside is not to the power of 4x cubed plus 4x squared. The 13 is not. So if I want to bring that power down, I actually have to separate this 13 away first. So I'll have ln y is equal to ln of 13 plus ln of cosecant of 9x to the 4x cubed plus 4x squared. And now everything in the parentheses is to that power. And just to kind of see what it would have looked like had we not had to separate the 13 away first, the big difference is 13 cosecant of 9x, all of that would be to the power of 4x cubed plus 4x squared. So in this case, the 13 is inside. That 13 is also being put to the power, so we would bring the power down first. So in this case, we would bring the power down first. Okay, so that said, we couldn't do that with what we actually had here. So I had to separate the 13 away first, and now I can bring the power down. So I have that this is equal to ln 13 plus 4x cubed plus 4x squared ln of cosecant of 9x. And here we want to be extra careful because that power that I'm bringing down, I'm not just multiplying the 4x squared by ln of cosecant of 9x, I'm multiplying the whole thing. So those parentheses that I just put here are really, really, really important. You need to make sure that if there's a plus or minus in that power, you put parentheses around it. A good plan would be to just put parentheses around it no matter what. Make sure you don't make any mistakes. So, oops. So we have these parentheses here. This 4x cubed plus 4x squared is in parentheses. And now there's no more simplification I can do. You might be asking, well, can I separate that 9x away? But remember, this is not cosecant times 9x. It is cosecant of 9x. Cosecant by itself makes no sense. I need that 9x. I need to be evaluating cosecant somewhere. So I can't separate them away from each other. So I'm actually done simplifying. So then my third step is going to be, is going to be to take the derivative of both sides. And we remember that the derivative of natural log y, we're doing the chain rule, and we get y prime over y. The derivative of ln 13 is 0. And then for this next part, I have a product rule. I have two things that are being multiplied together. So I do the derivative of the first, 12x squared plus 8x, times the second, ln of cosecant of 9x, then plus the first, 4x cubed plus 4x squared, times the derivative of the second. Well, here I have ln of cosecant of 9x, so I'm just using my log rule, which says g prime over g. So I have cosecant of 9x on the bottom, and then on the top, I'm going to have the derivative of cosecant. So we're going to have negative cosecant of 9x, cotangent of 9x. But here, because the 9x inside is actually a function, we have another chain rule. We have to multiply by 9. Then if we wanted, we could cancel out those cosecants right there. You don't have to. It's just that I see that they're there. I can easily cancel them out. So my final step here is to multiply y over. But when we multiply y over, we want to remember that y is actually the original function. We don't want to leave it as y because we know that it's 13 cosecant of 9x to the 4x cubed plus 4x squared. So we want our answer all in terms of x. We don't want an implicit answer. So here I'll have 13 cosecant of 9x to the 4x cubed plus 4x squared times this derivative that I have right here. Ln of cosecant of 9x plus 4x cubed plus 4x squared times negative 9 cotangent of 9x. So a mistake that I've seen a lot of you guys making is not putting these parentheses here when you have a minus. That's wrong. So this right here is not the correct answer, even though it looks really similar to the correct answer. In this, I'm doing 4x cubed plus 4x squared minus 9 cotangent 9x. But I want to be doing 4x cubed plus 4x squared times negative 9 cotangent of 9x. This thing is wrong without those parentheses. It's not just that it's ugly, it is wrong. Okay, so this is my final answer. Voila. And again, we said necessary. We had to do logarithmic differentiation here. Okay, now we're going to use logarithmic differentiation again on this giant ugly thing, and I want to know, is logarithmic differentiation necessary or just helpful? And in this case, I can answer that question right away. This is just a big mixture of quotient, product, and chain rules. There is no x's to the power of x's. When I have my power is x, the base is a number, and when I have an x as the base, the power is the number. It's not x's to the power of x's. So it's not x's to the power of x's, just a big mixture of product, quotient, and chain. Quotient and chain rules. And so what that tells me is that it is just helpful here. Just helpful. Okay, so step 1 of logarithmic differentiation is take ln of both sides. And I just want to point out that sometimes these particular questions are separated on your exams, but sometimes they're just thrown in there with regular derivatives, and it's up to you to recognize that you need logarithmic. With this type of question, the previous type of question, they'll always just be mixed in with other derivatives. So it will be up to you to recognize that logarithmic differentiation is necessary. And being able to do that is super, super key, because if you're unable to do that, then it's hard to even give you part marks on the problem because you haven't even started it. So it's going to be really key to make sure that you're capable of recognizing when it is necessary. All right, so here I'm taking ln of both sides, ln of this giant mess here. 7, 8x plus 9 to the 5th, cosine of 5x, 10 to the 2x, over e to the 5x squared minus 8x, ln x, cotangent to the 5th of x. Yuck! We're going to make this way simpler by now simplifying with our ln rules. So the first thing that I can do here is use my ln a over b equals ln a minus ln b to separate this. So this is 8x plus 9 to the 5th, cosine of 5x, 10 to the 2x, minus ln of e to the 5x squared minus 8x, ln x, cotangent to the 5th of x. Good. Now, in each of these, in the second one, I have 3 things being multiplied together. So I can separate that using ln a b equals ln a plus ln b. And over here, I actually have 4 things. I have the 10 to the 2x, the cosine of 5x, the 8x plus 9 to the 5th, and the 7. Same as in the last problem, it's going to be important to separate that 7 away, because if I don't, I'm not going to be able to bring the power of 5 down. So thinking of that constant as a separate factor is important. We want to separate it away. So now I'll get ln y is ln 7 plus ln of 8x plus 9 to the 5th plus ln of cosine of 5x plus ln of 10 to the 2x minus ln of e to the 5x squared minus 8x minus ln of ln x minus ln of, we said with trig functions, when you have a power, it's useful to bring that power to the end. That shows me that I can bring that power down to the front using my final log rule. This 5 I can also bring to the front. Note, if I had this, in order to bring that 5 to the front, I would have had to separate the 7 away first, because that 7 is not inside the parentheses to the power of 5. All right, so now we're going to use our final log rule. which tells me to bring the powers down. So I have ln 7 plus 5 ln of 8x plus 9 plus ln of cosine of 5x plus 2x ln 10 minus, in this case, remember lns and e's just cancel each other out. So this is minus 5x squared minus 8x. Notice I put it in parentheses, minus ln of ln x, then minus 5 ln of cotangent x. Okay, so I want to talk about these parentheses and these minus signs right here. So each of these is minus because it's kind of like this minus is getting distributed to each of the things inside when I distribute that line. So I'm doing minus, big open parentheses, ln of the first thing plus ln of the second thing plus ln of the third thing. So each of those becomes a minus instead of being a plus. In the same way, this minus right here is going to be distributed to each of those things. So I'm subtracting the whole thing, so we have to put it in parentheses. So it's each time it's kind of the same thing. I'm subtracting the whole thing. So now, I'm just going to erase those arrows because they're maybe a little confusing. Now I don't have any log rules left that I can apply. There are no powers. The cosine I can't separate from the 5x. The cotangent I can't separate from the x. So now I move on to my third step where I take the derivative of both sides. So this is y prime over y is equal to 0 plus 5. I'm just applying my log rule in each of these cases. 8 over 8x plus 9 plus cosine of 5x goes on the bottom. On the top, the derivative of cosine of 5x, which is going to require a chain rule. So I'm going to have negative sine of 5x times 5. Then this might be a little confusing, but both 2 and ln 10 are constants. So this is like x times a constant, where that constant is 2 ln 10. Then minus 10x, I'm going to just distribute that minus sign to get a plus 8. Minus, here we know this is 1 over x ln x because I'm doing like another chain rule here, 1 over ln x, derivative of ln x. Then minus 5, cotangent of x goes on the bottom and the derivative of cotangent x goes on top. Whew. Finally at step 4, where we multiply y over, remembering that y was the original function. So here, y prime is equal to this gross original function. I'm sorry to make you guys rewrite it because it's not fun and I know I don't want to do it. 10 to the 2x over e to the 5x squared minus 8x ln x cotangent to the 5th of x times 5 times 8. 40 over 8x plus 9 minus 5 sine of 5x over cosine of 5x. I don't need to simplify that. I don't have to write that as a tangent. I can just leave it like that. Then plus 2 ln 10 minus 10x plus 8 minus 1 over x ln x. And this next one, the minuses cancel out, so I have a plus 5 cosecant squared x over cotangent x. Voila, that is my final answer. Whew, and we only have one problem left. We are almost done with this thing. All right, so let's just do the last problem and get it over with. Here we're asked for a third derivative. This is actually a really simple problem. If you remember what we've said, we want to, when we are simplifying for higher order derivatives, avoid product and quotient rules as much as possible. Product quotient rule, bad. Power rule, good. And we've said that in order to make that happen, when we have one term on the bottom, we can distribute that one term to each of the things in the numerator. So here, I'm going to start off by simplifying before I even take a derivative. And if it's possible to make more power rules and get rid of product rules and quotient rules by doing that, you always should. So here I'm going to have 16x cubed over 4x squared minus 2x to the 1/2 over 4x squared plus 8x squared over 4x squared then minus 4x squared e to the 3x over 4x squared. So here, those 4x squareds cancel out. Here, the x squareds cancel out, and I just have 8 over 4 left. So 16 over 4, if we go to the first term, 16 over 4 is 4. X cubed over x squared is x, so I just have 4x. Minus 2 over 4 is a half, and then x to the 1/2 over x squared, that's like 1/2 minus 2. So this is x to the negative 3 over 2. So 1/2 minus 4 over 2, that's negative 3 over 2. And then here, I just have, like we said, 8 divided by 4 is 2, and then minus e to the 3x. This is going to be much easier for taking a higher derivative than what we started with. So now I'll have f prime of x is equal to 4 minus 1/2 times negative 3 over 2, x to the negative 5 over 2, plus 0 minus, this is a chain rule, e to the 3x times 3. So then f double prime of x is 0, so this is now plus 3 over 4 times negative 5 over 2, x to the negative 7 over 2, minus 3, then e to the 3x, and we have another 3 here. Notice, like, 2 of our things have already gone to 0. We only have 2 things left. So for our third derivative, it's actually really straightforward because we simplified first. If you didn't simplify first, this would be atrocious. So make sure you always simplify first. So then this is negative 15 over 8, x to the negative 9 over 2, so we have times negative 9 over 2, then minus 9, then e to the 3x, we're doing another chain rule, times 3. So here, I just want to be clear, this 3 is a constant, so it just like stays out front, and then we do the derivative. But then that 3 times 3 is a constant, so it just stays out front, and then we do the derivative. So here we end up with 15 times 9, that's 135. So this is equal to 135 over 16, x to the negative 9 over 2, minus 27 e to the 3x, and that is my final answer, and we are done with this group work. That's all. Bye, guys.